Okay, so we're going to do a warm-up that's not a traditional warm-up because we're going to review vertex form. Great. So on your quiz, you didn't have an issue with this vertex form, right? Y equals A times x minus h squared plus k. But we've looked at vertex form in a few different forms. You've also seen y equals A times x minus h squared, where there's no k, right? That just gives you a shift left and right. We've also seen ax squared plus k, where there's no parentheses, so you don't have an h value. And we've also seen when there's no h or k, or where both of them are 0. You had one of each of those, I believe, on your quiz yesterday. I lied. You didn't have this one, I don't think, but you still need to know it. Okay, all of those are vertex form. Your vertex always is your h and your k, which I think we've understood. We know that h is opposite. We know k is attached at the end. Okay, so this one's pretty obvious. We have an h and a k. This one we only have an h, which means k is 0. This one we only have a k, which means h is 0. And here do you see an h or a k? Which mean both are 0. Okay, this is our parent function. But we still struggle with that. Axis of symmetry. We're just doing like general. X equals whatever your h value is. Okay, whether it's 5, -3, or 0, it's x equals that number. Domain is always all real numbers, which I think everyone got that correct. Range is dependent on whether your graph opens up or down. So you have two options. You have y is less than or equal to k, because it's always your k value, or you have y is greater than or equal to k. When do I use which one? So when do I use the less than or equal to? What does my graph look like? It faces down. You have a maximum value and the graph faces down, so your y values get lower. So this is when your parabola opens down, which means it's greater than when your parabola opens up. Orientation. A couple periods had a huge issue with orientation. So orientation tells you if your graph opens up or down, right? So it opens up when A is positive. And you'll notice where A is located on all of these. So it's always in front of, really, your squared term every single time. Okay, so it's either in front of the parentheses, but the parentheses is squared, or it's legitimately in front of your x squared term, the number in front. If it's negative, it opens down. You are only looking at positive and negative for orientation. You don't care what the number is. When do we care what the number is? For shape. Okay, and for shape, you're basically taking the absolute value. You're looking at the positive value of that number. You don't care about the sign. We just want to look at the number. So if A equals 1, what happens to the shape of my graph? It's normal. There is no change. If A is less than 1, so typically this will be a fraction. However, you need to be careful and make sure your fraction's not larger than 1, like 3/2. Okay, if A is less than 1, what happens? It's a stretch, so it gets wider. I am okay if you write stretch or wider. Both of them are correct. I don't care. And then if A is greater than 1, what happens? A compression, or we can say it gets skinny. Oh, I ran out of room. What am I missing? Maximum and minimum. So when do we know if it's a maximum versus a minimum? Okay, so max or min. We will say that it is always the K value, right? No matter what, if it opens up or down, it's the K value. It's a max if your parabola opens down, and it's a min if your parabola opens up. But you will notice that all the numbers we use always deal with H and K. There are no other numbers involved other than looking at A to determine if it opens up or if it opens down. Do we need clarification on any of that? Yeah.
So like if it was -2, it's still skinnier?
Yes. Because, so the negative part tells you, so if it's -2, the negative part tells you your graph opens down. The 2 is greater than 1, so that tells you it's a compression. Okay, so when you're dealing with compression and stretch, just look at the absolute value or the positive value of your A term. The negative and positive initially just tell you if it opens up or down. Okay? Now, if you have a hard time identifying if it opens up or down or what the shape is, graph it and see what it looks like too. I just tell you to do the key features first to see if you can compare to make sure that your graph's correct. But if you think your math's solid and you can do the graph, then graph it first and then fill in the key features. Okay? Because if you say, okay, I think it's supposed to open down, and all of a sudden your graph opens up, there's two things you need to ask yourself. Did I do the math right? Like, should it legitimately open up? Or two, do I really not know what A is? And it does open up, so I need to change that. Okay, everything should match. Anything else? You sure? Okay. I will have quizzes graded. I'm going to be here, like I said, for Talon on Saturday. So I'm going to work on this on Saturday, and we'll go over them on Monday. Okay? Okay, so you should now be on page 59. Today is the 26th.
It's okay if we take these notes in behind you, correct?
Absolutely. Okay, so interpreting vertex form and standard form. There's a few different things we're going to look at today. We just talked about what vertex form was, right? Y equals, we'll just write it again, just to be sure. So vertex form, y equals a times x minus h squared plus k, where standard form is what? Does anyone know? Y equals ax squared plus bx plus c, which is what we've been dealing with all semester. Right? Now, all semester we've talked about quadratic equations. Does anyone know what makes these two quadratic equations? What the key thing is? What do they both have in common? An x squared. Okay? An equation is a quadratic equation if it has an x squared. Before we started doing graphing of quadratic equations, we graphed linear equations, and it was something like y equals 2x plus 3, right? What was the exponent on the x? On y equals 2x plus 3? A 1. Okay, that makes it linear. If the exponent is 1, it makes it linear. If the exponent is a 2, the highest exponent is a 2, it makes it a quadratic. So part of your test, I'm going to give you equations, and you have to be able to identify which ones are quadratic and which ones are not. Okay, but it's just identifying the x squared. So for instance, if I give you f of x equals x plus 1, is that a quadratic equation? No, because the exponent is a 1. So, not a quadratic. There literally will be a part on your test that asks you that, and all you have to do is say yes or no. Okay. What about f of x equals x squared plus 2x minus 6? Yes, the highest exponent is a 2. What about f of x equals 2 to the x power? Nope, not a quadratic. Are you seeing how we're identifying that? Okay, what about this one? So one person said yes. Everyone agree with that?
Yes.
You should recognize that to be what form? Vertex form. Which form was this? Standard form. Okay, so if you are asked to identify if a function is a quadratic function or not, you are looking for the highest exponent, and as long as it's a 2, you're good. If it's not a quadratic function. Okay? Can we move on from that?
Yes.
Okay. We are going to rewrite, so we get to do some like multiplying and stuff. We're going to rewrite a quadratic function from vertex form to standard form. So we have to know our order of operations in order to do this. Are we ready to try? So I'm going to give you y equals 4 times, ignore that. 4 times x minus 6 squared plus 3. So that's our equation in vertex form. We want it to be in standard form. So we want it to be in the form ax squared plus bx plus c. Where do you think we start? The parentheses. Okay, so how would I deal with the parentheses? So if I just gave you this, what does that mean?
Yeah, I thought it was a lot.
Okay, so we're not quite sure what this means. X minus 6 squared. What does that mean? X minus 6 times x minus 6, which means you would use the box or the FOIL method to multiply that out. Right? So really I could write this as 4 times x minus 6 times x minus 6 plus 3. But I'm going to box or FOIL that first. Most of us prefer the box, so that's what I'm going to use. Okay, so if I box that, I get x minus 6 and x minus 6. So inside my box, x squared minus 6x minus 6x plus 36. Okay. I still have this 4 on the outside. And I'm going to combine like terms. So I have x squared minus 12x plus 36. So this piece here turned into what's inside the parentheses. I have to leave it inside the parentheses for what reason? You still have that 4 on the outside that you have to distribute through. Okay, so let's distribute that 4. So we get y equals 4x squared minus 48 x plus 144. And then we still have that 3 at the end. I'm almost there. What's left? Add the two constants, right? So 4x squared minus 48x plus 147. Is that in the form ax squared plus bx plus c?
Yeah.
Okay.
So it's just following.
You're just order of operations. We're just rewriting it from vertex form to standard form.
So it's not hard.
Well, it shouldn't be hard, but again, we struggle with basic operations. Okay? That's in general for everyone.
Oh, okay.
Yeah.
You didn't even look at it.
We struggle with basic operations. We also struggle with, and I know I've yelled at y'all a few times, x minus 6 squared means x minus 6 times x minus 6. I guarantee you someone's not listening to me right now and is going to distribute this squared in and get x squared minus 36 and then finish it out. And then I'm going to put a big fat 0 on your paper and a sad face because you are not allowed to distribute the exponent. Okay? Can I give you one to try, or do you need to do one more with me?
No, but we
Try. Okay. I like the enthusiasm. So let's do y equals negative 3 times x plus 2 squared minus 1. So I'm going to give you a second. I'm going to pause the video so that you can try that on your own. I'm going to go through each step. Some of you may have been able to skip steps because you know what's coming, but just to make sure we're good. So y equals negative 3. X plus 2 squared means x plus 2 times x plus 2. I'm going to create my box. It's not a very good one. Inside your box, you should get x squared, 2x, 2x, and 4. Leaving you with y equals negative 3 times x squared plus 4x plus 4, and then minus the 1 at the end. So far, so good? For those of us that did it. Y equals negative 3x squared minus 12x minus 12, and then minus that 1. Your final answer. Y equals negative 3x squared minus 12x minus 13. How do we do? Yes. Yes. It's not an equation if you don't have y equals or f of x equals. We did okay? Sweet. Do we need another one of those, or can we move on? We can move on. Great. So we have been taking an equation, creating a table of values, and then creating a graph, right? Are you nervous about what I'm going to say? Oh, okay. Oh. I am now going to give you a graph or a table of values, and you have to be able to write the equation. Everyone's looking at me crazy. Okay. How about we're going to do it together first, so it'll be okay. So we're going to write the equation in vertex form. Okay, we're going to start by writing the equation in vertex form. And we're going to start off with a table of values. So my table of values are negative 6, 9, negative 4, 1, negative 3, 0. Here's my table of values. Now, you've created a table of values, so you should know some characteristics about it. Is there something about this table that you can tell me right off the bat? Samantha. The vertex is negative 3, 0. Remember I told you to always put your vertex in the middle and then build around it? And you know it's your vertex Y, other than the fact that it's in the middle. What else hints you off that it's your vertex? Jeffrey.
All other numbers are based around it.
Okay, the other numbers are based around it. Mackenzie? Okay, give me one. Okay, I'll answer the questions in 1 second. What else, Eliana? The K doesn't have to be 0 for it to be the vertex, but something about the Y. The Y what?
There's only one like Y value for the vertex. Like there's only one. Like for the other ones, it's 2.
Okay, so you're on the right track, but I'm looking for like specific words. What do we know about quadratics and parabolas and their graphs? They're symmetrical. These values are symmetrical, right? Both of those are 1, both of those are 9, which is how our table of values has looked. But that tells you that that's the vertex. Okay, what was your question? Let me answer that before I move on.
Why did you go 2 to 0? Like -2.
Oh, if you look here, it went from -3 to -4, and it skipped 5 and went to -6. So that's just the table. You're looking for the symmetry, okay? Because sometimes, so when we've had equations that have fractions, some people don't like to deal with the fractions, so they choose values that will work nicely in a lot of cases. Was that your same question? Okay. Are we okay with that? So we know V is our vertex. So our equation, our vertex form is y equals a times x minus h squared plus k. Where would I plug in, because I'm solving, where would I plug in -3 and 0 for what letters up here? H and K. Your vertex is H and K. So y equals a times x. Now, just like when we take h out, we take the opposite sign. When you put it back in, you do the opposite. So if this is a negative, it becomes positive, which should make sense because negative times -3 is a positive 3. And then k stays the same. Do I need to add a +0 at the end? No. Now, I still need to solve. I'm going to go back for 1 second. When we're writing our equations, everything is filled in except what for vertex form? X in. So look here. Everything has a number except what? X and Y. So we need to find H, K, and A. Right now I have H and K, but I don't know what A is. So if you think back to IM1, when you solved equations, you had to solve for B. When you were using y equals mx plus b, you had to plug in x and y. That's just a point on your graph. So we're going to pick one of these additional points and plug it in for x and y so we can solve for A. Which point looks the easiest?
0, 9.
I agree that 0, 9 probably looks the easiest. Okay, so I'm going to take 0, 9, and I'm going to plug it in for x and y so that I can solve for A. We're going to do a couple of these. Okay, so this becomes 9 equals, I don't know what A is, that's what I'm solving for. X is 0 plus 3 squared. What's 0 plus 3? 3, and 3 squared is? So this is really 9A. And then how do I get A by itself? Divide by 9, which means A equals 1. So the three things, again, I need are my H, my K, and my A. Do I know all three of those values?
Yes.
Okay, so the final step is to plug those three values back into your equation. So it's going to be y equals 1, because that's my A, times x plus 3 squared, because that's my H, and I don't have a K. This is your equation in vertex form. We're going to do a couple of these. But you solved equations like this and wrote equations like this in IM1. Yes.
You'll have to go to the backside.
Yes, I'm going to have to go to the backside.
So when we just leave it like that, like you have to
Mhm.
solve.
You don't have to solve anything. You're just writing the equation.
Oh, so.
Okay, let's do one more together, and then I'm going to have you try one. Let me adjust my life. All right, let's look at, so we're doing the same thing, but let's look at this table. So here's our new table. The process is still the same. So we're going to take vertex form, but we need to identify the vertex. What's the vertex? -2, -3. Everyone agree that that's the vertex? Okay. So when we plug it in, y equals a times x. What is h going to be here? A +2 because it changes signs, squared. And then I have this -3 attached at the end because I plugged that in for k. Are we okay with that? What point looks the easiest? Okay. -1, 1? Okay. Guess what? It doesn't matter what point you pick, we're all going to get the same answer. So if 0, 13 looks nicer to you, then use 0, 13. Okay, everyone will get the same answer. I circled -1, 1 for this, so let's just use that. So y is 1. I don't know a, that's what I'm solving for. X is -1 plus 2 squared minus 3. -1 plus 2 is 1. 1 squared is 1. I didn't leave room, but that should be a 1a, right? 1 times a. Minus 3. How do I get a by itself? Add 3. So if I add 3 to both sides, I get 4 equals a. Okay, so if that's what a equals, my final step is writing the equation. Do I know my h? Do I know my k? Do I know my a? All right. So y equals 4 times, and then really I'm just going to use the rest of this, right? Because this is where I started. All I'm replacing is the a. X plus 2 squared minus 3. Yes, Mackenzie?
In your head, did you box, where'd you get the 1 minus or equal to 1
This one right here?
Yeah.
So -1 plus 2 is 1. 1 squared is 1. 1 times a is 1a. So you don't have to do any kind of boxing or foiling here because you don't have a variable inside. Now, you at this point can tell me a lot about that graph, right? Hopefully. We already know what the vertex is. Can you tell me if it opens up or down? Up. So that's the orientation. What's the shape? It's a compression. Yes, skinny and compression are the same. What is the domain? Oh, good job. Okay, I'm going to have you guys try one. I want to see how far you can get. Okay, you'll notice this one skips a couple as well, but it's still symmetrical, so you're okay. So I want you to identify the vertex. I want you to see if you can solve for A and rewrite the equation. Once you're done, check with a couple people around you and see if they have the same answer. Shh. Your vertex was 2, 5. Giving you y equals a times x minus 2 squared plus 5. That's where you should have started. If you don't have that, then you're not going to get the right answer. So far, so good? Looks to me that the easiest point is 111. If you chose a different one, that's okay. So 11 equals a times 1 minus 2 squared plus 5. 1 minus 2 is negative 1. Negative 1 squared is still 1. So that's still a 1a, or just a plus 5. If you subtract 5 from both sides, you get a equals 6. I have my h, my k, and my a. So my final answer is y equals 6 times x minus 2 squared plus 5. You're a genius, so you're never wrong?
Most of the time.
Okay.
Even geniuses have their mistakes.
Okay, let's be very clear. You use the vertex for h and k. You cannot use the vertex for x and y. You cannot plug in the same point. You have to pick a different one. Now you know. Okay, so sometimes you're going to get a table, and sometimes you're going to get a graph. It's the same thing. Okay. We don't even have to do that. So for right now, you're just going to sketch it, because it'll be given to you nicely.
Is it like curved?
Here are your points. Negative 1, 0, 0, 5. And mine's just a sketch, so it's not perfectly drawn to scale, just FYI. Okay, but here's my graph. Again, it's a sketch, and it's not a fabulous one, but it'll work.
So on our homework, we have to graph that.
No. So you'll be given this graph. We're going to now write an equation. It's the same thing. What's the vertex?
2, 9.
2, 9 is your vertex. Okay? So just what we did. Y equals a times x minus 2 squared plus 9. We plugged in the vertex. What else do we have to solve for? A. That's what we're looking for. So we pick another point. Which point do you like the best?
5 and 0.
5, 0, 0, 5?
5, 0.
5, 0. Okay. If you like 0, 5 better, use that one. So I'm going to use 5, 0. So y is 0, a, x is 5.
No, that's easy.
Okay, it's the same thing. You just use a graph versus the table. So now let's simplify. 0 equals 5 minus 2 is 3. 3 squared is 9 times a is 9a, right? Plus that 9. What do I do to get a by itself?
Subtract 9.
Subtract 9, giving me negative 9 equals 9a. Divide by 9, a equals negative 1. Does it make sense to you that a is negative 1? Why? The graph faces down. So the nice thing about having the graph done is if you got a value that didn't match the shape of the graph, you did it wrong. Okay, you have an easy check. It's not the same with your table of values necessarily, but when it's a graph, if this came out to a positive 1, you'd be like, something's wrong. And it's not the graph because it was printed for you. Okay, final step, writing your equation in. So y equals negative 1 times x minus 2 squared plus 9. We will spend more time on this, but I want to see kind of where you're at and where you're struggling. Tomorrow is going to be a full review day because we're going to start graphing in standard form on Monday. Maybe. No, you don't have any more days off until school gets out.
That's kind of, that's neat of the district.